Hi, my project is on big data case study in telecommunications. Telecommunication companies collect and store a lot of data, uh, which could include call data from various calls, like when was the call made, how long is the duration, what number is the call made to, and all that, and also like the data about the network usage and also about customer data. So they are an ideal candidate to harness big data technologies and all this data to improve their business models. There have already been examples where telecom companies have used big data to improve certain metrics, like improve their quality of service or remove bottlenecks from their network. Telecom companies, for example, also engage in marketing to customers either via SMSs or calls, and by using big data technologies and data such as location data, the call records, they can provide better marketing campaigns. This will allow for a higher success rate and also increased customer loyalty. In this case study, I will look at how mobile location and call data can be used to look at the load on cell towers and how quality of service can be improved. Usually, telecom data is hard to come by because it's not really to made available to the public. So I was able to get a data set from MIT Media Lab, which has phone Bluetooth location data from 94 subjects, which include students and staff. Um, so this is called the reality mining data, and a link to it is in the references. It was conducted from 2004 and 2005 at the MIT Media Laboratory, and the subjects consisted of students and staff. And there was a mobile phone logging software installed on each of their phones, which collected data such as location from cell tower IDs, also Bluetooth information. Um, and I will use only part of this data set for this project. And this data set is in the form of a MATLAB matrix. It's in a .mat format. I firstly used MATLAB to extract the data that I need in the form of comma separated files, and then I used pig to analyze these files. The data that I was able to get from the MIT dataset has various kinds of information, and there are different metrics that can be analyzed from this information. I tried to look at few of them. For example, I used the location data from the towers to get what is the busiest tower among all of them. This is a simple metric, and but it tells us where we can focus resources in. Another example would be to divide the time of the day into different segments, and for different hours of the day we can see what is the peak time when the traffic is the highest based on this location data, and this would allow us to uh, allocate more resources during that time. And the thing is analyzing the call data to see what is the peak time for the calls and what are the kinds of calls being made. For example, are the calls voice calls or packet calls? Also, if we can look at what is the peak time calls are being made and then correlate them with the location data, we can also see which tower is being used at what time of the day, and this will give us a lot of insight when we come up with planning for infrastructure and stuff like that. uh, the About the data set, the reality mining project was done from 2004 to 2005 at MIT Media Laboratory, and it collected call logs, Bluetooth devices, cell tower IDs, application usage, and phone statuses. So there was an application which was installed on every phone, and it collected all this information. And for example, the phone logs consist of the times. It looks something like this: a timestamp, description, a direction, direction meaning outgoing or an incoming call, duration of the call, and the number to which the call was made. Bluetooth information looked something like the time, the device IDs, and location information consisted of the time, the cell area, and the cell towers. And for you can look at the raw data here. It is in the form of a MATLAB matrix. So, for example, a communicom has all the information about the communication, the phone calls, and other stuff like that. While LOCS location has all the location information. Um, so I used MATLAB. I wrote a small MATLAB script to process this and only get the information which I needed, which is currently the location data and the communication data. So, for example, after processing, uh, I was able to get this form of a comma separated file in which this is the communication data. So the first number is the ID of the user, the second number is the timestamp of the call, the third is the event ID of the call, the fourth is the contact number for in the phone, like and -1 means there is no contact, or if there is a contact it will give you the contact number in the phone book. And the fifth is the type of call going out, either packet data or voice call or text. The next is the outgoing or incoming, and the last is the call duration. And this had 180,000 records. The next one is the location information. It had around 3.3 million records, and around the file size around 120 MB, and it consisted of the user ID, the timestamp, and the location information. The location information is of the form of the area ID dot the tower ID. So this could be something like 2412 is the area ID and 700 is the tower ID. And I used the Cloudera Quick Start VM for running all the pig scripts, since pig is already installed in that and it's quite easy to run it. This you can see a pig editor running in a browser in the Cloudera VM. I firstly loaded all the comma separated files into HDFS in the Cloudera VM, and then I used pig scripts. This is an example of the pig script. In this example, I was trying to rank the towers based on how busy they are using the location data. And firstly, I loaded the data into pig, and then I grouped them by the tower, and then I counted all occurrences for every tower, and you can see the output here. So again, from this I know which tower is being pinged the most for location data. um, it's pretty straightforward example, I guess. In the second example, I was trying to find out what is the busiest time of the day using the location data. So first, like the previous example, I loaded the data from HDFS, and then I generated the time for each ping for the location, and then I got just the hours. I removed the dates and the minutes and the seconds, and just got the hour. And then I grouped them based on the hour, and then I counted the number of occurrences. So the output looks like this. So the busiest time is around 12 o'clock in the afternoon, and 9 o'clock, and 11 and 10 o'clock, and it goes way down. And the lowest one, if I remember correctly, is uh, 12 o'clock at night. For the third example, I looked at the communication data set to see what kind of calls are being made the most. So here there are three kinds of calls, either voice calls or packet calls or text messages. Um, Obviously, text messages don't have the duration, but voice calls and packet calls have a duration. And first, I loaded the dataset into HDFS and into PIG, and I generated I generated just the call type and the duration for each record, and then I grouped them based on call types, and then I summed up the duration for each call type, and this is the output of that. So voice calls, you can see, are around 877,000 seconds, while packet data is around 942 seconds. As expected, messages are 0 seconds. So this is another metric we can get. There are there are also other metrics and insights which can be analyzed from this data set. As you can see, there are a lot of information in it. Some other examples could be looking at the app usage of the users and see what apps are being used the most. Also, location of the user can be referenced with map data. You could use this location data to target the user for businesses in those locations. In summary, I'd like to say that big data technologies are pretty useful for telecom companies, especially because they have a lot of data regarding location, cellular usage, calls, text usage, and stuff like that. And it is hard to get publicly available data, but if you can get your hands on it, it will be pretty insightful to look at it. Thanks.